Big Data,
Big data, analytics, AI, cloud, digitization. These are the main topics of today. In for more than 4 years, we have been able to support Mercedes with all these topics, especially for the Factory 56 in Sindelfingen, the most modern, digitalized, high technology factory in the Daimler network. Based on the Azure platform, many use cases for the production area have been implemented already. The experience with these use cases were only one of the key factors for our own path in the Azure Cloud and our Microsoft core partnership of MHP. That is why I'm especially delighted to be able to welcome Christine Puritz. She is responsible for Big Data and AI at Mercedes-Benz in Sindelfingen, and she is our contact person for the project. Thank you very much. Well, digital transformation keeps all industry sectors busy in Germany. But this is especially true for the automotive industry. And this is why we with our teams are also very busy in shaping the transformation in Mercedes-Benz operations. Why do we do that? Well, because this change is a step towards digital transformation and it entails a lot of opportunities. Over the last decades, we changed the processes within the automotive industry. And now we want to seize the opportunity with Industry 4.0 to get out the last percentage points of KPIs and machine availability. A big opportunity is to use resources in an efficient way, to relieve employees where automatic processes and robots can be used, and to use the resources to use the intelligence and know-how and knowledge of the employees to feed intelligent algorithms to roll that out on a broad basis. This is the opportunity that we also want to seize. Of course, the benefits to increase efficiency come not just overnight. The road is quite rough. Also, the challenges are known to us, but we tackle them actively. From the IT point of view, we see the challenges mainly in the enormous complexity of the automated processes to transfer and map that in an IT and data world. Just imagine the following situation. To supply material to the assembly line. It used to be transported with a forklift truck, and if they met a kind of an obstacle, then, well, it was ignored or it was put aside. In the Factory 56, we only use AVGs. This makes it necessary that we implemented this in the software and the programming of the AGVs, because only if we tell the AGV beforehand what to do to set an alarm so that an employee can come to get rid of the obstacle in the way, then it makes sense. This is a complexity that is not there in an analogous process. Another challenge is, for instance, that we have an enormous data volume that we now need to transport, to transmit, and to process. This is also a task for IT. We need to create the basis for enabling that. The good news is that we have already faced these challenges and the infrastructural prerequisites have already been set in the Factory 56. Almost all our machines, robots, AGVs, all devices that we use in production are IoT ready. That means you can send messages or notifications. For instance, master data, I am robot 57 and I'm standing in hall 56. But also status quo information that is helpful for the seeing the battery status of a device, or also see the wear status of a machine. And the most important class of messages that we get are messages on the process that the machine or the device is supporting. Information, time rows, the voltage, current, whatever, during a welding process, for instance. This information makes it possible for us to analyze the processes. The IoT readiness is one decisive factor for our infrastructure. It's great to have this readiness, but we need another infrastructure component to be able to transmit the messages. And this is what our MSB is doing, the manufacturing service bus. All the messages of all devices and machines are collected by this MSB and are addressed to the right recipients. The MSB works as a postal office, so to say. You can send the notifications to different recipients. This could be simple web applications where you can see the current results. And when we talk about AI, it also has to be efficient storage systems that receive the messages. And it's no surprise for you that when we talk about big scalable storage systems, that we have created a cloud infrastructure where we can store the data for big cloud use cases. It's a Microsoft Azure environment that is scalable and flexible, where we, for instance, map the assembly of our vehicles. There's one special thing to that. We achieved to establish a cloud environment that allows us at a reasonable risk level to also upload sensitive data. It is an environment that is so safe that we can take the risk. It also shows that the restrictions, well, there are restrictions, of course. This brings along restrictions with regard to flexibility, but this is handleable. So we can or could implement our use cases very well. So it's manageable. So these are the three pillars our use case development is based on. IoT readiness of our machines, a manufacturing service bus that enables to distribute the data or information, and a cloud-based infrastructure that enables a scalable assessment and evaluation of the data. The best infrastructure does not generate any added value. This is the enabler. This is the invest that we had to do here. We need infrastructure, but Daimler is not earning money with that. And the center of application development was the customer right from the start. We as a partner, as IT partner, we collaborated right from the start, and we had a business product owner on board right from the start that supports the products, that controlled the requirements, and the products that we have on the market today were also essentially co-designed by this party. For us as IT, it was always important to take the customer's perspective. One example, from the IT, it's always very easy to build a dashboard for an application, but for the end user, it is a horror. In a digitalized world, if the customer needs to offer another tool that is not integrated into the existing processes, then the user will just not accept this new tool. So you need to take on the role of the customer and ensure that the new products, the new analytic solutions fit perfectly in the process world of your customers. This was an important success factor that worked very well in the development of our assembly technology.
And these
essential bases result in creating benefits even today with our dashboards. The interaction with the components, with the customers, enables to tap efficiencies. In production, this means mainly the machine availability that is increased. Based on the data that we use, we get insights, and based on the insights, we can proactively react. That means we get rid of malfunctions before they happen. And with this, we increase machine availability. Another important point is the recognition and detection of quality problems or issues or weaknesses right very early in the process. This is an aspect that we consider in our assembly. We check quality criteria very early. We compare them to the as-is state. And this is a very nice example that a wiring harness that is incorrectly installed, and at the moment where it is incorrectly installed, you can change it very easily. But once you have assembled all the seats and dashboards, etc., it's really, really difficult to correct this error. Gap sizes is another quality criterion at Mercedes-Benz AG. To track it, to check if this is still within the tolerance, and then to react right away if you detected an error. This saves a lot of effort and a lot of time.
Digital
transformation asks a lot from our customers and departments, also asks a lot from our engineers and planners. I've just mentioned it. Digitalization of processes also means that production planners, for instance, need to use applications and programs they wouldn't have thought of 10 years ago. So it's now even more important to support the customer here, to also support them when they develop an AI solution, for instance, so that they accept the solution at the end of the day. This is what we did in our project. First of all, we took data from our machines and devices and visualized it on a user interface. So we just showed the user, see, this is the information our machines generate currently. And then when you look back and you realize, well, the speed of an engine is 0, and the engineer thinks about, yes, it makes sense because the plant failed then, and was switched off, then this gains trust and acceptance. And then you can slowly go forward. Once you establish this step, then you go forward and use KPIs and threshold values, and then you try to bring in automation. And then we say, see, when you take a look at your data, then you could have already known that the machine will fail because the temperature increased, and this is a sign for wear. So now you can say, okay, we put in a threshold value of a temperature of 75 degrees, and then an alert is given, and then you take a look at your machine, and maybe you can then correct the situation before a real error happens and before we have downtime of the machine, because the machine sends an alert on time. And once you achieve this, then the prediction is not far away, because then you can explain, okay, the temperature does not increase from 1 second to the other, from 50 to 75 degrees Celsius, but you see a development. You see an evolution over the past hours. You see a trend. Every 30 minutes, we had a temperature difference of 1 Kelvin. This is information that you can use and explore, and you could do a retrospective analysis, and you see, okay, the temperature increases steadily, so in 4 hours you will reach the temperature threshold. So then you can say, okay, while we have our lunch break, we do the repair of the machine because it is switched off anyway. And with this, you can plan more precisely. So you support the customer right from the start, and you step by step ensure that the customer sees the added value of the new system. But it does not mean that you replace any steps. We still have the dashboards showing us the current world, the actual situation, just to use that as a basis to come up with new ideas, to also take other improvement approaches. And to be honest, that's not the end. There is much more to that. We are just at the initial point. We created the basis, we implemented first use cases successfully, but that's not it. The potential is much more. And this is why I'm looking forward to the dashboards, to be able to continuously improve the applications and roll out to all Mercedes-Benz plants, and with this we can create more benefit for Daimler AG.
Vielen, vielen Dank.
Thank you very much for this very interesting presentation and for the insights into the Factory 56. It's a great surprise for me, and I think it's remarkable what you did in the past years, and all the experience and competencies that we gathered there can also be used in other industries and other companies for successful projects, and we are looking forward to that. Thank you very much.